Dear students, in the last class we discussed about distribution system and we defined the distribution system. One more thing is what is substation, definition of the substation, classifications of substation, and what are the equipments are used in the substation. All these points we discussed in the last class. Now today we are going to discuss distribution system. What is a distribution system? Already we know about the distribution system, the conductor system by which electrical energy is conveyed from a bulk power source, that means a substation, to the consumer is called distribution system. So in between the substation and the consumer is nothing but a distribution system. Here in general the distribution system is the electrical system between the substation fed by the transmission system and the consumers meters. See here the definition. In general the distribution system is the electrical system between the substation fed by the transmission system and the consumers. So I am saying that in between the substation and the consumer is nothing but a distribution system. It is generally consists of, so the main thing, the main parts, so main consists of a feeder, distributor and the service mains. So that is shown in the diagram. So here it is the diagram. Here feeders, distributor, service main. Now we need to know about these three terms. So very important we need to know. And feeder, what is in a feeder? See here it is in the diagram. SC indicates that substation, and we have the feeders and we have the distributors also, and in the diagram service main also available. So what is meant by feeder? What is in feeder? A feeder is a conductor which connects the substation or localized generating station to the area where the power is distributed. See the definition is, it is a conductor, it is a conductor which connects the substation and where we are distributing the power. So it is a conductor, it connects the substation and where the power is distributed generally. So we won't take the tappings from the feeder, okay na? We won't take the tappings from the feeder. That's why the current is remains same throughout the feeder. Current is same throughout the feeder. So next thing is distributor. Here the definition of the distributor is, a distributor is a conductor from which tappings are taken for the supply to the consumers. So here the diagram is there. See, you can observe the diagram. There is a distributor. So AB distributor is there, BC distributor is there, CD distributor is there. So DA also a distributor. So from that distributors we are taking the tappings. That's why we are saying that from which tappings are taken for the supply to consumer. That is nothing but a distributor. The current through a distributor is not constant because tappings are taken at various places along its length. So the current is not same. Where in the feeder the current is same throughout the feeder, but in the distributor there is a difference in current. So while designing a distributor, voltage drop along its length is the main consideration, since the saturatory limit of the voltage variance is plus or minus 6% of rated value at the consumer's terminals. Now coming to a third one, service mains. A service mains is generally a small cable which connects the distributor to the consumer terminal. See here the service mains is nothing but it is a cables, so small cable which connect the distributor to the consumer terminals. So these are the arrow marks indicates that service mains. So it connects the distributor and the consumer. So arrow marks indicate that tappings taken from the distributor. Now coming to a primary and secondary distribution. So we are having the depending upon the rating of the distributor voltage, the distribution of system are mainly classified into two types. One is the primary distribution, that means high volt distribution atom. Next second one is secondary distribution, it is nothing but a low voltage distribution. Now coming to primary distribution, as we know, we can generate the electrical energy and we can transmit the energy, and from the transmission we can step down the voltage, right? We can step down the voltage. See here, the primary transmission lines transmit the power from the generating stations to various primary substations through EHV lines. At these primary substations, the voltage is stepped down, see, stepped down to 33 kV or 66 kV by means of step down transformer. See, we can step downing the voltage from higher levels. So it is up to 33 kV. So it is up to 33 kV or 66 kV. So from the primary substation, the electrical power is transmitted through secondary transmission lines 33 kV to various secondary transmission substations. At these secondary substations, the voltage is further stepped down to 11 kilovolts or 6.6 kilovolts. So using an step down transformer. So here the definition of the primary distribution system. So listen that our primary distribution system is defined as a place from which the power is distributed. See, primary distribution system is defined as a place from which the power is distributed between secondary transmission substation to the primary distribution substation or bulk supply consumers. So we are defining that primary distribution system is defined as a place from which the power is distributed between the secondary transmission substation to the primary distribution substation is known as the primary distribution system. So here the voltage is up to an 11 kV. So here the diagram indicates that it is an primary distribution system. So here it is, we are supplying the energy. This type of voltage is to a big type of consumers. So whoever running the industries, whoever running the factories, for that purpose we can supply the electrical energy whatever their needs, whatever they need the energy we need to transmit. So sorry, we need to distribute. So here they needed 11 kV for the industrial purpose. That means they are the big consumers of electrical energy. So we are distributing the electrical energy to that big consumers. So here the diagram is primary distribution. Now coming to a secondary distribution. So secondary distribution is nothing but it is defined as a place from which the power is distributed between the primary distribution, that is primary distribution to domestic appliances and commercial and small industrial consumers. So here primary to we can step down the voltage. See, whatever the voltage we said that 11 kV by using a delta to star transformer. See, I wrote something here. At distribution substations, the voltage is stepped down to 400 volts, that means line to line voltage, and 230 volts phase to neutral by using an delta to star transformer. So we are defining the secondary distribution system, that means where the place of primary distribution between domestic purpose or commercial purpose or small industry purpose. So this is the definition of secondary distribution system. So next diagram indicates that. See, the diagram indicates that. So secondary distribution system. So here you can observe that I told already the voltage between line to line. The voltage between the line to, see, I wrote something here. So check it once. Line to line, that means two phases is 400 volts. That means two in between any two phases, R or RY or YB or RB, whatever may be, it's the voltage between any two phase is 400 volts. That means we can supply that voltage for the irrigation. That means three phase supply it is. And coming to a single phase supply, we can take one phase and one neutral, it can having the voltage of 230 volts. So we are using here delta star transformer, that means 3-phase distribution transformer by we can 11 kV to 400 volts. So we can use here single phase supply and 3-phase supply also. This is the explanation of secondary distribution system. So here the line diagram of a total, that is primary distribution and secondary distribution. Check out this here, primary transmission also is there. See, check out the diagram of this one. Here the generating station is there, and where is the step down transformer is there, and one more thing is primary transmission is there. That means primary transmission is 400 kilovolts to 33 kilovolts. So here the check out the diagram. Primary transmission is there, secondary transmission is there, and after the 33 kV primary distribution is there. That means we are step downing the voltage 33 to 11 kV. That is nothing but a primary distribution. After the 11 kV we are step downing. Again we are step downing by using a step down transformer, that is 11 kV to 400 kilovolts. That is secondary distribution. Here one diagram, line diagram of a power system. Now coming to, we know that three terms, that are the feeder, distributor, service main. Now what is the purpose of feeder? See, I wrote something here. Feeders are the conductors which connects the substations. See, I wrote that. Feeders are the conductor which connect the substations to the area served by the stations. So that's what I wrote. So purpose of the distributor also, from the distributor only, we can take the number of tappings, and service mains which connect the consumer terminals to the distributor. Alright, these are the feeder, distributor and the service mains. So here the schematic diagram of the distributor system. Schematic diagram of the distribution system. See here, a small cable service main. Service main is, see here the indication of feeder and distributor, service main. See here I wrote something, see here from the substation I taken the feeders, number of feeders 1, 2 and 3, 4, 5, 6 feeders are there, and the distributors are also available. See, check out the figure of this one, a schematic diagram of distribution system. Here the feeder is there, distributor is there, and service main is there. Service main is nothing but, see the diagrammatically here indicating that service main is nothing but it connect the consumer and the distributor. See here the distributor, and feeder is nothing but a substation to where we need to serve. This is the diagram. Now coming to next one, classification of distribution system. So on the basis of type of current we can classify this distribution system according to the type of current, AC distribution, DC distribution, and basis of construction, that means overhead or underground, and basis of the service, that means general lighting or power, industrial power, railways, street lighting, etc. On the basis of number of wires also, 2 wire, 3 wire, 4 wire distribution system. Next, basis of scheme of connection. This is what important here, scheme of connection. So radial distribution system, ring distribution system, parallel distribution system, interconnected distribution system. This one very important, you can learn it. So on the basis of scheme of connection, that means first one is radial distribution system, ring distribution system, parallel distribution system, and fourth one is interconnected system. So first one is radial distribution system. So here I wrote something. This is the schematic diagram of radial distribution system. So schematic diagram of radial distribution system. So one substation is there, feeders are there, and distributors are there. From the distributor we are tapping the loads. So in radial distribution system, the primary feeders radiated from the distribution substation and branch into a sub feeders, and the laterals which extend into all parts of the area served. See here, from one feeder we are taking a distributor. Number of feeders are connected to a particular substation, and particular feeder to we are giving a distributor. From that feeder we are giving to a distributor. From distributor itself we are taking the tappings. See, we are taking the tappings, that means loads. So here the system mainly used to serve the light and medium density loads. So this type of, that means radial distribution system is used to serve light and medium density load areas, that means small towns or rural areas and rural areas. See, from the figure, feeder OC supplies a distributor AB at point A. Hence, the distributor AB is fed at one end only. See, this is fed at one end. Distributor fed at one end only. So, OA, the feeder OA is connected to AB. That means this distributor is fed at one end only. That means point A itself. So, what are the advantages of this one? So, it is simple construction. So, low investment. That means simple construction and low investment. Say, mainly disadvantage of this one is, in this system, every consumer is depend on the single feeder only. This is the main disadvantage. If any fault occurs on the feeder causes, every consumer will get affected from the power cut. So, the end of the distributor and nearest to the feeding point will be heavily loaded. Next, in this system, the end consumer will get affected from the serious voltage fluctuation due to the variation of load. Coming to the ring type distribution system. Ring distribution system. So here it is, the loop type is there. So here it is, the loop type is there. Check out this diagram. So here A, B, C, D, E, F, G, H, A. It is like a closed area. That means it is in a closed path. So here, that's why we are calling as a ring distribution system. So ring distribution system is a closed loop circuit, starts from the substation bus bars, makes a loop through the area to be served and returns to the substation. Figure shows that the single line diagram of ring main distribution system. In this system, the substation supplies to the closed feeders of A, B, C, D, E, F, G, H, A. The distributors are tapped from the different points of B, D, C. Check the diagram. B, D, distributors are B, D, E, F. Like this, the distributors are there, feeder through the distributor transformer. So, advantages. What are the advantages here? Lesser voltage fluctuation terminals at the consumer terminals. Reliability is more compared to radial system. Repairs and maintenance is very easy. So, and lesser voltage drop. And every consumer is supplied through a two feeders. Check out this diagram. Every feeder is supplied by the two feeders. That means every distributor, every consumer is received the power from the two distributors, right? Two feeders. Coming to an interconnected system. What is meant by interconnected system? Interconnected system is nothing but, this is the diagram we are showing here, diagram of an interconnected system. When the feeder ring is energized by two or more than two generating stations, two or more generating stations or substations, it is called interconnected system. So check this, here in this diagram we have the four substations, right? We have the four substations. Check out the diagram of interconnected system. We have the four substations are there, right? Four substations are there. If any fault occurs in any substation, we can collect the energy from another substation also. We can distribute from another supply through a feeders. Alright. So advantages. What are the advantages? It increase the service stability. Second one, efficiency of the system is more, and any area fed from one generating station during peak load hours can be fed from the other generating stations. Now coming to a comparison of radial and ring main distribution system. This is important, you can learn. Check it. Radial distribution system and ring main distribution system. First one, the radial distribution system. The voltage drop is more in the radial, voltage drop is less, and it is not reliable. Coming to it is reliable. It is not economical. Ring main distribution is more economical. the consumer is fed by single distributor only, where the radial distributor, where in the radial distributor, where from coming to a ring main distributor, the consumer is fed by two or more distributor. Fifth one, there is no provision for the interconnector in order to rise the potential. So there is no possibility of interconnection, but here the possibility of the interconnection is available in ring main distribution system. Now coming to a calculation of voltage drops. Calculation of voltage drops in AC distribution system. According to that, on the basis of loading, that means basis concentrating loading, uniform distributed loading, and coming to on the basis of feeding. This is what here important. A fed at one end, fed at both ends. In that, equal voltages, unequal voltages, and C fed at the center of the distributor. D fed at the any point of the ring distributor. These are the very important here. So first thing is distributor fed at one end itself. Distributor fed at one end itself. See, check the diagram here. The schematic diagram is there. Distributor fed at only one end. AB here diagram. See the diagram. AB is the distributor, right? From AB is the distributor. From the distributor only we taken the loads, right? We tapped off the loads. In this type of feeding, the distributor is connected to supply at one end. The loads are taken at different points along the length of the distributor, and AB and end is A. Distributor fed at the end A, and the loads are I1, I2, I3 are tapped off at point C, D, E respectively. See the silent features. The current flowing in the various sections of the distributor away from the feeding point goes on decreasing. See here in the middle, in the AC place, in the section of AC, the current is high. Sorry, there is a mistake. I1 plus I2 plus I3. Where in the section of CD, the current is I2 plus I3. Where in the section of DE, the current is only I3. So we can check this. While moving from A to B, the current is decreasing. So that's why I wrote the point, the current flowing in the various sections of the distributor away from the feeding point goes on decreasing. Second point is the voltage across the loads away from the feeding point goes on decreasing. Hence, minimum voltage occurs at the point load E. Third one, in case of fault on the feeder causes, total distributor will be get affected, so that continuity of the supply will be interrupted. Next, coming to a distributor fed at both ends. See, distributor fed at both ends. A fed at A, it is fed at B. So in this type of feeding, the distributor is connected to the supply, means at both ends, and the loads are tapped off at different points along the length of the distributor. So figure shows that a distributor AB fed at ends A and B. The loads are I1, I2 and I3 are tapped off at points C, D and E respectively. So silent features of this one. If any fault occurs on any feeding point of the distributor, the continuity of the supply is maintained from another feeding point. This is what important here. In case of fault any section of the distributor, the continuity of supply is maintained from other feeding point. So next, the area of the cross section of the conductor required for the double end fed distributor is much lesser as compared to single feeder. Next, the load voltage goes on decreasing as we move away from the feeding point, say A, and reaches maximum value when we reaches to the other feeding point. Next, distributor fed at center. In this type of feeding, the center of the distributor is connected to the supply mains. That's shown in figure. It is equivalent to the two single fed distributors, each having a common feeding point and length equal to half of the total length. So here AB distributor connected at point C. The feeding point is connected at C. Now coming to a ring main distributor system. In this system, the distributor is in the form of a closed loop. See, check out this diagram. Ring distributor. See, it is in the form of closed loop shown in the figure. It is equivalent to a straight distributor fed at both ends with equal voltages. With equal voltages, the two ends being brought together to form a closed ring. The distributor ring may be fed at one end or more than one. More than one. See in this diagram, see here it is in a feeder and we are taking the tappings from I1, I2, I3. So it is like a closed area. So see, that's why I wrote something here. It is equivalent to a straight distributor fed at both ends with a equal voltages. So equal voltages. The main So the distributor ring may be fed at one or more than one point. So this is by this method we can calculate the voltage drop in the DC distributors, right? First one is and distributor fed at one end, distributor fed at both ends. That means in that we have the equal voltages and unequal voltages. Third one is distributor fed at middle, and fourth one is ring main distributor. So by this I am concluding today's lesson. Tomorrow we will discuss on the calculation part of this voltage drop calculations. So thank you.